welcome back to another video. In this video, we're gonna discuss about ionic bonding, which is another type of chemical bond. All right. So it would be a very new term for you guys, but we'll be looking into it step by step. All right. So the learning outcomes of this video would be you'll be able to know and understand what an ionic bond is. All right. And similarly, we will discuss about the properties with regard to ionic bonding. So if you say this particular compound is a ionic bond, then what are the properties it has and why? All right. So all of that we'll be discussing in the upcoming slides. So first thing what we want to know is what is ionic bonding? That is the first thing. So ionic bonding, so we know the concept of bond. Okay, we know the concept of bond. Bond is something, two substances being bonded. So ionic is the new word. So ionic means this is a bond that is found between metals and non-metals. Okay, so we know in the periodic table we have groups 1 to 3 mainly, which consists of metals, and then groups 5 to 7 consists of non-metals. So any reaction between the elements in group 1 to 3 and with any element from group 5 to 7 will give you a ionic bond. All right. So how does this ionic bond happen? So we know that these two guys are the guys who are participating, but how do they react? That's what we're going to do, look at in the next thing. So this bond has a electron transfer. So when I say electron transfer, that means one of the reactants or one of the substances needs to give away their electrons, whereas the other reactor needs to accept those electrons. All right. When I say about electrons, we refer to the giving away of the outermost electrons. That is the electrons that are present in the outermost shell. Okay. So those are the electrons that we are considering about. So for example, metals, what they would do is they would give away their outer shell electrons, whereas the non-metal would accept those outer shell electrons that are given from the metal into their outermost shell. All right. So basically, metal gives away electrons. Or you can say metal is a electron donor, and non-metal is a electron acceptor. Okay. And the other point that we need to know is that these ionic bonds, they form a regular lattice. Now lattice, we know lattice means a particular pattern, particular regular pattern that is followed throughout the structure. That is what we call as lattice. Okay. So we have made life easy, without saying, regular pattern going here and there. We just use a simple one word, lattice, which is easy. And these lattices are very, very large. Now you don't see them. If you see them in 2D, you don't really see, but if you project them into 3D, you definitely see that, oh yes, these ionic bonds are really, really big structures, massive structures. So they have very, very strong ionic bonds. All right. But no worries, you won't be questioned about any of the 3D structures, but it's good to know, good for knowledge. So I have here a 3D structure. So this is actually sodium chloride. Okay, you can see sodium, and you can see chlorine. Okay, so you can remember when we did about when we spoke about writing of chemical equations, we did about we knew how to get the formula of sodium chloride. We know the sodium is in group 1, so it acquires a +1 charge, and chlorine has a -1 charge. So now we know. So then we know we cross it, and then we get NaCl. We cross the two numbers, okay, and then we get NaCl. So now we know what is it, and now we know the name. Now we know the name that is given to this. So this is a 3D structure. So you can see there is there are so many chlorines, there are so many sodiums, okay, That means each positive charge and each negative charge, they are attracted to each other. So when they attract, that means there's a very, very strong electrostatic force of attraction. So you can see, for example, here now if you take this sodium that is on the topmost face, the middle sodium, the sodium, because sodiums are in red color. Okay, so this red color ball, you can see um, how many chlorines are attached. How many? 1, 2, 3, 4. So there are 4. So imagine the amount of electrostatic attraction between them. Okay, there's a high electrostatic attraction. So that's why we said that they have very, very strong ionic bonds. This you don't see in 2D structures, but if you draw it in 3D only, you are able to visualize it. Okay. Then we come to these examples. Now the key point of these ionic bonds is understanding what happens. Okay, so be mindful at this stage. You should be very, very clear about this, that in chemistry, okay, we have two types of elements, metals and non-metals mainly. Metals are able to give away the outermost shell electrons, and non-metals accept outer outer accept out electrons to the outermost shell. Okay, so in a reaction, if one reactant is giving away electrons, the other reaction should be accepting those electrons, right? They can't just if someone's giving, they can't just disappear and vanish in the space, right? Someone needs to take. If someone's giving, someone needs to take it. So the giver or the donor will be the metal always, and the acceptor will be the non-metal. So we are looking at this magnesium oxide. If you you can just pause the video, because you can just pause the video, go and write down the reaction between magnesium and oxygen, and see what is the formula for magnesium oxide, and then we can see. Okay, so I do recommend for you guys to just pause the video and try it on your own. Okay, but here I'll just go on explaining. All right, so you can see now magnesium, as you can remember, as for the periodic table, it falls in group 2. So if it falls in group 2, that means it has 2 electrons in its outermost shell. There are 2. There are 2 electrons in this outermost shell of magnesium. Whereas oxygen falls into group 6, right? So that means it has 6 electrons in its outermost shell. So as what we said, metals are the donors, and non-metals are the acceptors. So what does he do? The metal tries to get rid of his outermost electrons. So he has 2, he tries to give away 2. Okay, so why does he do that? Why does he give away those 2 electrons? Because he wants to make his the element stable. He wants to make himself stable, because we know when the electron shells are completely filled, okay, or as we can say the outermost shell electron has 8 electrons, then we say that the element is stable. So what he's trying to do is he's trying to react with oxygen and gain that stability. Similar for oxygen. Now oxygen has 6 electrons in the outermost shell, but when having 6 in the outermost shell, it's not stable. He needs to have 8, right? So what he does is he wants to gain electrons from somewhere. It's more easy for him to gain than lose. All right. So they are a matching couple, right? So because magnesium is there, magnesium is willing to give two electrons away. Oxygen is willing to take 2 electrons. So no problem. So the 2 electrons of these 2 come and join here. So you can see here. So magnesium gives away 2 electrons. So when you give, you gain a positive charge. So in this case, he gives not just 1 electron, he gives 2 electrons. So he obtains a positive 2 charge. Whereas oxygen, what happens to oxygen? Now oxygen has gained 2 more electrons. See, you can see here the red color dots. They are the electrons that came from the magnesium. Okay, so the 2 electrons from magnesium have come and joined into oxygen's outer shell now. Okay, so what has happened? So now what has happened? It has gained those 2 electrons, and now he has become a 2 minus charge. So each time you gain an electron, you get a minus charge. So in this case, he got 2 electrons, so he obtains a 2 minus charge. Okay. Now, if you can see, if you count the electrons in this outer shell of oxygen, you have 8. So it's stable. If you consider the electrons of magnesium in the outermost shell, it's also 8. They're both stable. So they have reacted in a way. The electron transfers happen in a way where magnesium and oxygen are able to obtain stability. They have become stable ions at this stage. Now, earlier they were elements. Now they have removed, magnesium has given away his electrons and become a positive 2 charge, whereas oxygen has gained those 2 electrons and become a 2 minus charge. So they are happy now because they are stable. They have reacted in a way where they are able to gain stability. So elements, that's why they react. Elements, whatever reaction that happens, why do they react? Because they want to gain stability. Okay. So this is the way that magnesium and oxygen react and are able to obtain these particular charges. So remember always that these charges, and remember that always, okay, a metal will always gain a positive charge, and a non-metal will gain a negative charge. Okay. So let's look at another tougher more example, because we like to make things tough, and yeah, we can make things very tough. Okay. Now, if you can see in this, okay. Now here we are reacting magnesium and chlorine. Okay. Now here we have a small issue because magnesium, if you can remember, by now you need to know that magnesium is in group 2, so it has 2 electrons in the outermost shell, so it wants to get rid of those 2 electrons and obtain the stability. And he's reacting with what? He's reacting it with chlorine, which is a non-metal found in group 7. Now, if he tries to react with one chlorine only, there's a small issue. Because chlorine is in group 7, it has 7 electrons in the outermost shell. Okay. So that means it needs only one. It needs only one electron from the metal to become stable, to obtain a negative charge and become stable. But magnesium is being too generous. He's giving 2 electrons, but chlorine says, hey, I can't accept more than 1 electron from you. So what happens? Does the reaction not happen? No, the reaction does happen. So instead of having 1 chlorine, we are having 2 chlorines. So the 2 electrons that are being donated from the magnesium one of the electrons goes to one of the chlorines, and the other electron goes to the other chlorine. So now they're matched. So both of the magnesium will be balanced as it gives away the 2 electrons, and the 2 chlorines, after accepting 1 electron from the magnesium, it gains stability. Okay, so you can see here magnesium gives away the 2 electrons and it obtains magnesium 2 plus. There are 2 chlorines, they gain 1 electron from each of the magnesium, and it obtains minus on each of the chlorine molecules, I would say. Okay. So in this case also, you can just, because we know the idea of, balancing chemical equations, we know all of that. You can just, after watching this video, you can just go and, or maybe pause this video for now and then go and look at the reaction between magnesium and chlorine, and then see whether it matches to what we say here. All right. So this is one of the, things that you have to think in this case, but it's pretty easy. Okay. If you understand valency properly, so you understand this as a very well. Okay, if you don't understand valency, then this becomes a bit difficult. Then we come to the properties. Okay, then we come to the properties. Now here we have a property which is they have very high melting and boiling points. Very high melting and boiling points. Why? Because we spoke about this. Now, for example, in this picture, same picture we're going to look at the 3D structure of sodium chloride, right? So sodium chloride, you can see this sodium. I'm again taking this example of this sodium because I can see much clearly and I can explain it. This sodium has 1, 2, 3, 4 chlorines attached to it. Okay, as I can see at the time for the time being. So what happens? So there are so much of attraction. This positive Na plus, and there are 4 chlorine minuses. It is such a very, very, very strong force of attraction between them. So if you want to, I don't know, if you want to melt them, it's pretty difficult. Okay, but this is in terms of structures. Okay, 3D structures. Okay, and there are different types of ionic bonds that you find in in the world that require a very, very large amount of energy. Sodium chloride is just small example that I'm referring, because sodium chloride is a thing that you find in your houses also. Yeah, you can do a small research and see where do you find sodium chloride in your house. Yeah, so if you look at the next property, which is the solubility in water. Okay, they are ionic compounds are very soluble in water. Why now? Because water, when you react something with water, these ionic bonds tend to break back into their ions. So water has the ability of breaking them back into the ions. As a result, they will become soluble. Okay, so that's why I said at home do a small research and see where sodium chloride is found in your house, and then this second property also matches to what I said. All right. Next thing is the conduction of electricity. Now, be mindful that ionic bonds, when they're in solid form, they cannot conduct any electricity. Why? Because to conduct electricity, we need free ions. We need free mobile ions to move here and there and conduct electricity. But when they are in solid structure or structure like this, now see here, everything is being bonded. They are all attached to each other. They can't move. All right. But when they are in molten state or when they are dissolved in water, these ions can move freely here, and the chlorine can move somewhere else, sodium can move somewhere else. As a result, they can conduct electricity. Okay, so be very mindful that solid structure, solid form of ionic bonds cannot conduct electricity, but molten, and when they are mixed in water, they can conduct electricity. All right. So in this video, what we discussed about ionic bonding. We learned what ionic bonding is. Okay, we learned that it is a transfer of electrons. The metal was said to be the electron donor, and the non-metal was the electron acceptor. As a result, the metal gains a positive charge after donating his electron, whereas the non-metal gains a negative charge after obtaining that electron. Okay, we looked at different scenarios. We looked at magnesium oxide. We looked at a tougher example, magnesium chloride, right? And we understood that all these reactions happen because these elements need to become stable. They want to become stable. To obtain stability, they react. Okay, and in the most chemical way, we were able to prove that. Okay, and then we came up to the properties. We discussed about the properties. Then we were able to relate those properties in terms of this ionic bond. Okay, with regard to the boiling points, solubility of water, solubility in water, and also the conduction of electricity. All right, so that's the place where we end this video. So I hope you guys understood, and I will see you again in another video. All right, thank you so much.